Okay. So when we talk about sig figs, this is just a crash course right now, and then we'll go back and you guys can show me your skills here. So often we're looking at where uncertainty begins, right? When we're talking about sig figs. And so we call it digit uncertainty, right? Or uncertain digits. So we're not sure about it. So like I gave you guys the example of my weight, right? So my only going to the one spot, and then that's where it always fluctuates at that one spot, right? Yes. And so if the number is exact, we don't have to worry about significant figures because in that context, that number is exact. Okay, so that means is that we know that every number after that is going to be exactly 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, because it's an exact number. Right? Okay. Does that make sense?
Yes.
So we talked about those leading zeros. We talked about the lagging zeros. So here's examples of leading zeros. So that very first number has 2 sig figs, right? Where the second number has 3 sig figs. Again, because these zeros aren't going to count, right? For significant figures. Okay. Only the numbers, the non-zero numbers in this case are counted. Okay. Now these are examples of lagging zeros. So since there's not a decimal here, these zeros are just considered placeholders. They let us know that we're talking about a large number, right? But there's 4 significant figures. Okay. This guy is an example of having 5 significant figures. Again, these 3 zeros are just placeholders. They let us know that, again, it's a large number, right? But the non-zero numbers are going to be the ones that we consider to be significant. We're unsure about these numbers, although they're just acting as placeholders. So this here is an example of captive zeros. Now, when we know that you have a 0 between 2 non-zero numbers, that number becomes significant. Now, these are examples of, again, captive zeros, right? These 2 zeros are in between 2 non-zero numbers, so they're going to be captive. So they're going to count for significance. Okay, where these zeros are just going to hold that spot to let us know that they're zeros. Okay. Now here we have 5 sig figs. All of these numbers are significant because we took the time to put the decimal and then we followed it up by zeros. So we're saying that we are sure about those. So all of those numbers are going to be significant.
So if there were to be, let's say, 4 zeros after the decimal, then they would all count.
That is correct. Okay. So here is another example. So in this case, we have 8 sig figs. So that's 1, 2, 3, 4, 5, 6, 7, 8. All of these numbers are going to be considered significant because we put that decimal there and we followed it up with 2 more zeros. Okay. So if we're taking that extra time, because really, do you have to write 0.00 normally?
No.
Not usually. No.
I could have just said this is 504,000, and that's fine, right? I wouldn't have to say 0.00. So that 0.00 is extra. It's also letting my audience know, or you guys know, that these zeros are going to be important. They're significant. Okay, and we know that these zeros are obviously going to be important because we have the decimal point there, right? Does that make sense?
Yeah.
Okay, so let's test this out.
Wait, what did you say?
I said, okay, let's test this out.
All
So
right, all right.
put a couple of numbers up there. Okay, do I have any volunteers?
A is 3.
B is 5.
Okay, so what I want you to do is, on the other side of the blackboard over here, tell me how many sig figs. I'll write up here, sig figs. Or significant figures.
You want us to write it in?
I want you to write it in.
On my computer, I can.
Okay, so I'll write it in for you since I like you so much.
Aw, so
Thank
sweet.
you.
You're welcome.
Does that say 10 to 23 power?
That's 10 to the 23 power.
Okay.
Let's see. Okay, who's gonna do D for me? It can't be anybody who's done A, B, or C. Gabriel, did you hear what I said? Did you do C?
I'm working on the last one.
You can do it on your paper, but I just need you to do one on my board.
I did B.
You did B?
Yes.
And I know Jacob was gonna do A, but Jacob, do you wanna do another one instead? Are you there, Jacob? Let's see.
Is everything okay?
Yep, we just need an F. No, we don't need an F, but we need somebody to answer letter F.
We're gonna just be like 1 with 23 zeros.
How many sig figs would it be?
1.
Is that a 13?
No, that's 23. It's 10 to the 23 power. 23.
Wouldn't it just be 23 significant figures?
No. Nope, it would not be 23 sig figs.
Would it be 1?
No, it would not be one sig fig.
Oh,
Oh, wait,
Can't exit.
24, right?
It wouldn't be 24, no.
No? Oh,
25?
No,
Would it
it
be
would not
10?
25, nope.
Wouldn't it be
10.
230? Well, 230.00.
It would not be 230 sig figs either. So whoever put F, that was correct. F would be 3 sig figs. Okay? So
how
let's
did they
put-
get that?
3?
Because if we look at because this is scientific notation. Right? You get scientific notation. So that's 1. We took the decimal point and put 0, 0. So those are becoming significant. All of these times 10 to the whatever power it is, right? That isn't part of that significance. That's just letting us know that there's a whole bunch of zeros following, or there'll be a whole bunch of zeros in front of it.
So it's not part of the significance, so it's just the 3 from the first one.
First 3 right here, that's it.
Okay, I think that makes more sense.
Okay, so the first one, how many sig figs? Somebody said A. Who was the first person? My verse
Wait, and you said A? It was 3.
A. Are you sure?
It's 1.
It is.
Oh,
There's
Yeah.
no
she's right.
dot.
It is 1 sig fig, right? Because
What?
we don't have a decimal point there, right? So these zeros are just placeholders. They're letting us know that it's 200, not 2, right? But that doesn't mean that they're significant. So really, it could be 199, or it could be 206. We really wouldn't know because they have those zeros there. And so those zeros are 203.
Okay.
Does that make sense?
Yeah.
Yes. Yeah, I got the other one right that was like that, and I got that one wrong, so I get it now, but
Okay, so B, you said 5.
Mhm.
Does everybody agree?
Yes.
Yeah.
so if I owe you $200.50, you're gonna want all $200.50. That's how I remember that.
That's right, because I'm greedy. That's right. Okay, and C,
I answered it. It's 3.
okay, does everybody agree with that?
Yes.
Yes.
Wouldn't it be 7?
No.
Nope, it would be 3. Because again, these numbers here in front are just holding spaces. They're letting us know that we have a very, very small number. These zeros up here.
Oh, okay. What if there was a 1 instead of the 0 point?
If there's a 1 here in front,
Uh-huh.
And you count all of it.
yeah, then you'd have to count them all.
Oh, okay.
So right now, since there isn't, these are not significant, the ones that are circled. So those wouldn't be considered significant. Only these last 3 are considered to be significant. Okay, what about D?
No.
Then
No.
it's supposed to be 4.
There's supposed to be 4. That's correct. So D should be 4. Okay, so which 4?
The last 4.
The last 4. Because again, we took time to add them on those zeros following the non-zero numbers, right? We're only going to do that is if we know that those numbers are significant and they have importance to us. Okay, what about E?
Yes.
3.
3. That's right. It's these 3.
Because 3 is like A, or E is like A, right?
That's right.
Okay.
Okay, and then we've already talked about F.
Mhm.
Okay.
Pretty sure I have a fever.
Oh my God.
Well, stay home. You're at home, right?
I'm in the dorms.
Perfect. Then you're at home, right?
Yeah.
Okay, so since we're doing addition and subtraction, do you guys want to go ahead and do these for me?
Okay.
Cheers. Or who wants to be voluntold?
Hold on.
Um,
I'm still writing it down.
Now make sure your math adds up.
I'm too tired for this.
it's 32,360.
You can't write?
Hmm?
I say you can't write it in?
Oh, okay. 1 sec. The exact number or the number with the significant figures?
Do the exact number and then show me where
Okay.
the figures are.
Mm. And then.
Oh, this is hard. Hold on.
Oh, I know. That's why I want you guys to do it, so you guys can appreciate my pain.
No, the pencil's annoying. Hold on. My 5 looks dumb now.
I'll take a guess. I'll say it's.
2, 1, 3, 5.
Oh wait, it could be.
This one's 1, 0.
That's a big decimal point.
I couldn't see it, and I want to make sure you guys can see it.
Okay.
3, 6. So there would be 7 right here, right? Shouldn't we count all of them?
Nope. So how would you determine how many sig figs we have? They want to look at
Oh
what.
wait, didn't you like draw lines or something? Like you did this
That's correct.
for the first 2, I guess, and then the next one is like right here. Oh, and then this one's like right here. Right, something like that. And then I don't remember after that. So wait, okay, so this one. So then in this row, there's 2 significant figures. And then this one, there's 3, 5, 6, 7. So would there be 9?
Nope. So why are you drawing the line?
I don't remember. I just remember you separated it after like the significant figure stopped or something like that.
Okay. So that, yeah, that's right. So we drew the line. So like for that first number,
Oh, your line came out so much nicer. How weird. Okay, so the first number is 2, which is right here.
okay, so that's where.
So
You mind
you
if
want
I
to
move your
stop?
numbers over?
What did you say?
So do you mind if I move your numbers over?
Yeah, go ahead. I don't like that. What did you do? That looks weird. Oh, okay.
Okay.
Okay, so 2, 1, 5, 6, 1.
So those first 2 numbers, significant ends after the 1, right? After both. So that means that those numbers, anything that's beyond that would be considered insignificant, right?
Okay.
And then in our next number, significant ends after the 1 as well. Okay, and then our last number, significant ends after the 3.
Yeah.
So which line am I going to use to determine whether I'm going to be rounding up or leaving it alone?
The one with the least going on or something like that?
The one that's more to the left, or yeah, to the left-hand side. So the green line, right?
So 0.011.
No, 0.06, right? Because then you take a look at the number that's following it. So are we going to round that number up or are we going to leave it alone?
Oh, you're looking at the last one.
No, you're looking at this number here. The 5, right? So if we look at the
Are you
5,
looking at the 5?
yes, why are we looking at the 5?
Yeah.
Because that determines whether we round it or we don't.
That's right, because if you look at the number here,
Because of the last green line, so that's where you go to that number?
that's right. You look where the green line and you go to the right of the green line. And then you take a look at that number. If that number is greater than 5, we round up. If the number is less than 5, we leave alone. Now it's at 5 exactly, but there's number following it. So that's kind of like being, is that going to be greater than 5? Or is that going to be less than 5?
So it's 1.017?
That's right.
Because
The answer would be-
it goes up 1?
That's right. So the answer would be 1.017. That's correct.
Okay. Think got it now.
Okay. And let's see. So the person that did the one at the bottom, that is correct. The answer would be the 8,000.
So I have a stupid question.
Okay. I may have a stupid answer.
Okay, so you said, how do we decide like where to go? Like it was based off of the green line. So is that kind of like when our math homework would say round to the nearest, what was that, like 10/100ths place or something?
Yes. Yes.
Is that the same thing?
It's the same concept. Yes.
Oh, same concept. Okay, cool. Thank you.
Okay. And 3 sig figs for the, oops. For the last one. So do you guys see that? You see how it's done?
That makes so much more sense.
Okay. And you notice
Food on my shirt.
the people who did this, they did not write just 32, right? They recognize that it's 32,000, right? And that those zeros are needed to hold that place, right? You know that 32 and 32,000 are not the same. Okay, questions? Concerns? Cash? Kool-Aid? Excellent.
Okay.
Okay. Oh, did everybody get that? I'm sorry, I was rushing.
Yeah.
So now the ruler is where we left off from last week.
Yes, the ruler's where we left off from last week, right? I'm working through it. Okay, so if you guys take a look at this ruler, and you can't see any of the numbers on it, right? But in theory, it says it's between 6 and 7 meters. Okay. So in this case, it can be recorded as 0.6 plus or minus 0.1, or 0.7 plus or minus 0.1. So as we add more, we know that the number is going to be 60 centimeters or 70 centimeters, and it's with some certainty, but we have some uncertainty because we know it's between those two. So we know that we can definitely say it's between these two for certain, right? But we're not sure, is that 65 or is that 64 or is that 63? We're not sure about that, right? Yes, no, maybe?
Yeah.
So it could be 65, it could be 64, it could be 63. So one thing that we could do is we could sit there and put plus or minus 0.01 meters, which is meaning that we're adding that, we put it in centimeters, adding that 1 centimeter, right? To make it plus or minus 65. So that could really be 63 or it could be 65. We're not 100% sure. So then if we get a little bit closer, right, and we'll see that it's between 64 and 65. but kind of closer to 64. Right? So then we take that estimate, we can say, well, it's 64.3 plus or minus 0.1 centimeters. Or we could say it's 64.2 plus or minus 0.1 centimeters. Okay. Then we could get a little more reliable if we could get a better ruler, right? Now, the key is that, if you notice, each of the instruments that we're getting is better, because in the very beginning, we couldn't see anything. Now we have all of these lines, and so we can get more and more accurate of how long that piece of wood is. Okay, are you guys with me?
Yeah.
Okay, so remember when we were talking about my scale, this goes back to my scale. So my scale was only going to the one spot. If I used Brooke's scale, you know, Brooke has money. So, you know, Brooke told me she has a job, so she has money, right?
I got bills, honey. I got bills.
Okay, I know her scale is better than my scale, right? Because hers goes to the 10th spot, right? And Gabriel, you know, Gabriel's doing so well that he doesn't have to work. So he must really have money, right?
No, I'm too
know.
poor, so I get it from the government.
So then I know Gabriel has an even better scale than Brooke, right? And because we're taking these numbers from, I go to Brooke's house, I go to Gabriel's house, and we take weight from all of them, and then we compare it to my scale as well, right? We know that my scale has the most uncertainty towards it. So we have to use my scale to sit there and use to determine the number of significance, because we're using my scale in addition to Brooke's and Gabriel's scale, right? Does that make sense?
Yeah, like at a prison I worked at, I went to all the scales in each clinic and weighed myself and was trying to see if there was a difference. It was like 1 or 2 pounds on each one. It was like different every time.
Yeah. Yeah. What were you doing in prison?
I work in prison.
Oh, okay. I was just making sure. I'm like, huh, is there something I should know?
Yeah, I love prison. It's pretty great.
Okay. So how many sig figs do we have here?
3?
That's correct. What about the second one?
2.
Do you all agree?
Yes.
Anybody disagree?
Yeah, it's okay.
Anybody want to fight about it?
No.
Nope.
Okay, good.
I can first.
It's too early for drama.
Drama.
Okay, we already talked about how
It's
to
too
draw,
late,
right?
man. It's tiring.
Oh yeah, I guess it's too late for drama. That's right. Too late for drama. Okay, so rounding off, right? We've already talked about that 5 being that marker, right? So we know
Yes.
that if it's exactly at 5, we're gonna leave it alone, right? If it's above 5, we round up. If it's below 5, we leave it alone. Okay. We've talked about the addition and subtraction rule. So if we go ahead and do this, if you guys, they did that, they added it for you. All you have to do is put the numbers in there. Come on now. So if we write those numbers in, can you tell me where significant ends and begins for each one? Can you draw the lines for me?
How do I get the lines to draw as straight as yours?
There is a straight line, so there's a curvy line and there's a straight line.
Oh, it's like at a slant.
Yep.
Okay, so like this one stopped here.
Like which one?
319.5 up there. Whoa.
Yep.
All right.
That's a pretty straight line. Look at that.
Okay, and then this one would be right here. So for that one, that'll be there. This one will be here. Oh. There. Is it okay if I use this line for the last 2 since they're both in the same spot?
Yeah. That's fine.
My masterpiece is complete.
Okay, but are you sure about the line that you drew here?
For which one? Where'd your mouse go? I can't see.
For the second one, the second number.
For the second number, it ends at 6, right?
Does it?
Mm,
No, ends at 0.
That's right, because we took that extra time and put that extra 0 in there.
Shit.
So I'm gonna slide it over for you. Okay, so where am I gonna, which number am I gonna use to round?
Hold on. The 3?
308.
No, the 8.
What was that?
You're gonna use the 3 to round.
I'm gonna use the 3 to round. That is
The
correct.
300 place one.
This one right here. Okay, so is that greater than 5 or less than 5?
Less.
So it'll stay the same.
So it's gonna stay the same, so my answer is gonna be
389.80 or just 3.98 or
39.8.
389.
Yep.
Okay.
Okay, question? Great. Good. No questions, we're moving forward. Okay, so we've talked about how it's done with multiplication, right? So if we take a look at this number, how many sig figs do we have for that first number,
3,
right? How many do you have for the second number?
4,
And then the
Five.
one on the bottom?
1.
4.
Sure. It's 4.
Oh, 4, because there's a decimal.
That's right. Okay, so then how many sig figs should I have?
8.
Just told me there's 3. So what is the rule for multiplication and division?
I don't remember.
Anybody remember? It's a good thing you guys didn't have a quiz today.
Thank God.
I think it just says it right there at the top.
Round off the answer to the same number of significant figures
As,
as the smallest number of significant figures in any measured quantity.
okay, so what is the smallest number?
3.
3. So then how many sig figs should I have?
3.
I should have 3. So then what should be my answer?
0.06.
How did you get 0.06?
Which number are you looking at?
The answer. The
Oh.
unrounded answer.
0.08.
Zero
Would that
point
be-
zero eight.
That-
Would that be 3 sig figs?
no, that's 1. So
That's-
you have to add 2 more numbers.
Okay, so then I added, is it gonna be 2, or is it gonna be 0.08?
Oh, it wants the 3 numbers to be 3 significant figures at the end.
You want 3 sig figs, right?
Oh, okay. That's right.
So which one is right?
The bottom.
Top
The
one
one with the 3,
The one with the 3. So why do we, is the one with 3 right?
because it's rounded.
The 8.
That's right. So we're looking at the 8. I'm gonna decide whether we're gonna round up or leave it alone. Is 8 greater than 5?
C.
Okay, so since 8 is greater than 5, this guy's gonna go up 1.
I'm gonna make you guys turn your cameras on because I feel like no one's paying attention.
I am.
I'm too tired.
I'm like the only one. And Gabe.
Yeah, this is a class of 2. Everybody else is tapped out. Don't worry about it.
It's
Their
a night
quiz,
class.
It's
their
hard to.
quiz will show it, will reflect what they've done. So we'll have a quiz on Wednesday.
Oh God, this Wednesday?
This Wednesday on this material.
It's not an exam, right?
No, it's a quiz.
But it's still
Okay, thank God.
But the exam is going to be coming up here shortly. So
Oh
next-
God.
I'll be opening
Thank
up
you.
the exam and the practice exam.
Oh, yay.
Thank you, Dr. Henry.
You're welcome. Okay, so we've talked about the US customary units before, so we don't need to go over too much, but we'll kind of brush on it again. So we know that 1 inch is going to be equal to 2.54. 1 pound is going to be equal to 453.59227 grams. And the volume, 1 gallon is going to be equal to approximately 3.785411784 liters. That would be exact. I should say approximate.
Yeah,
Okay,
very specific.
so these are some other conversions for length and mass in the US customary system. Okay, a soft drink manufacturer is converting from USCS units to the metric units. If the quart bottle initially is to remain at the same volume, what number in milliliters should be printed on the label?
So it wants us to do the liters to milliliters?
So we're going from quarts,
Oh,
milliliters.
oops.
Okay, so we're starting off with 1 quart.
So divided by 4. Oh, no, wait.
So
1
you're
gallon.
saying, so that if you go 4 quarts equal 1 gallon.
Yeah.
Okay. So then gallon is going to be on top, quart's going to be on the bottom, since you said we're going to be dividing by the quart. Okay. And 1 gallon is going to equal how many liters? One gallon equals how many liters?
3.785411.
3.785, and we're going to use that 4 and just going to round to that 4, right? So that number following the 4 is a 1, right?
Yes.
So we're just going to put liters there. Okay, so then gallons are going to cancel out. Quarts are going to cancel out. And then we're left with liters. So what else do we need to do? How do we get to milliliters from liters?
Times it by
Well,
1,000.
Yeah, there's,
Okay. So you're saying for every 1 liter, so times
There's
1,000.
1,000.
So we're going to put 1,000 on top, 1,000 milliliters. Okay, so then that's going to equal. What do you guys get?
I don't know why, but when you write it on a chart like that, I get so confused.
Again, just multiply the numbers on top and divide it by the numbers on the bottom.
Okay.
Oh,
What do you guys get?
I'm tired.
946
Okay. So 946.
milliliters.
So
Right, we're dividing.
that's right. You multiply the numbers on top, and then you divide by the numbers on the bottom.
Right.
Okay. So if we're talking about sig figs, how many sig figs should I have? Since I only wrote down 1 quart.
Which number are you looking at for how many sig figs?
Everything else is a conversion, so you'd only start off with what your given is.
Oh, so this
So
is
the
1.
number that I just circled. So
1.
1. So how many sig figs should I have for my answer then?
1.
I should have 1. So my answer should be
900.
900. That is correct. 900 is correct. 900 mils.
Oh, is it because you went off of the 6 and rounded the 4 down? Or is that wrong?
Yes. No, you went off the 4, right? Because we need 1 sig fig based upon what was given, right?
Oh, okay.
Number. So this is 1 significant figure. So you'd have to look at the number that's next to that 1 significant figure, and then you decide, are you going to round it up or are you going to leave it alone?
Okay.
So are we going to round the 9 up or are we going to leave it just as 9?
Okay.
Okay, so if we left it as 9, then we put zeros in those spots to hold that space to let us know it's greater than 9. It's 900. Okay. Questions?
No.
I'm still kind of confused a little. So all right, we multiply the top and then divide that and that result with the bottom numbers.
So the lines that are going this way up and down, right? That means
Yeah.
multiplication. The lines that goes right here. So I'm going to draw those. The line that goes up and down, I'm going to put those in pink. Okay. So those lines here,
Multiplication.
that's multiplication. So we're multiplying
Yeah.
those numbers across. The number that is in orange.
And that's division.
Orange, that means division, right? So you multiply 1 times 1 times 3.7854 times 1,000. Then you divide that by 4, and you divide it by 1, and you divide it by 1. But we know if you divide it by 1, it's going to be whatever the number was, right? So we don't worry about that. You just have to divide it by that 4.
All right, thank you.
No
But
problem.
wait, and then wait, no, actually, how do we get 900 milliliters?
How do we get 900 milliliters?
Yeah.
Because we're looking at the number of significant figures. We started off with 1 because it says the quart bottle, so that's 1 quart, right? So if we start off with 1 quart, that's 1 significant figure. So then my answer would be 1 significant figure. My final answer, okay? So we have a question that says, where do we get the 3.7854? Does anybody want to answer that for?
Could you
That
repeat?
is the equivalent to a gallon.
So that would be the equivalency to 1 gallon. That is correct.
In
So that's
liters.
just the conversion factor. So you would either gotten it from the table that we just saw, or you got it from the table that I gave you guys, right?
I have a
Yes.
question about that table.
What about it?
You said that we would be able to use the periodic table that you gave us on our exam in the future, but will we be able to use that periodic table or that whole packet?
The whole packet,
Okay, cool.
except on the final. The final has
Okay.
its own periodic table and a little packet that you guys can use, or a little application that you guys can use. Okay? So if we do conversions from Celsius or temperature conversions. So if we're converting from Celsius to Fahrenheit or Fahrenheit to Celsius, we can basically use this equation here, right? So if we're going from Fahrenheit temperatures that we have, let's say, what was the temperature today?
98.
Okay, so let's use 98 degrees. then that's gonna give us our degrees in Celsius. So what did you guys get?
I'm still dividing, 1 second. $36,
You should
but
get
I'm not done yet, so, hold on.
So we should get,
36.1?
are you sure?
No, hold on.
Isn't it 36.666? And
Okay,
it keeps on going.
36.
Yeah, what she said.
6, right? Degrees Celsius. Right? So if we're doing this, we have 2 sig figs. This number is part of our conversion or how we're looking at it. So we're looking at 2 significant figures that are being subtracted by 2 significant figures. So if we looked at that final number up top, that's going to be how many sig figs? 198 minus 32 is going to be what? I mean, 98 minus 32. I believe that's 66.
Yes.
Okay, and then we divide 66 by 1.8. So 2 sig figs divided by 2 sig figs. So our answer should be how many significant figures?
Right? No, 2.
Would it be 4?
Nope,
3.
nope,
5.
nope.
Oh, 1. No, 2. It's 2.
So the correct answer is 2. So we have 2 sig figs on top and we have 2 sig figs on the bottom. The rule is when we do division, it's 2 significant figures. So then it would be, my final answer should be
37.
37 degrees Celsius. Because we use this 6, it's greater than 5, so we're going to round it up to 37. Okay, questions?
No.
No questions? Good. Okay, so what if I have 37 degrees Celsius? And I want to change that to Fahrenheit. So now I have TC is equal to 37 degrees.
Hmm.
Would you do 37 times 1.8 plus 32?
37 times 1.8 plus 32. And then
This
that's
is backwards, right?
temperature. Yep, in Fahrenheit.
Oh, cool.
So what do you get?
98.6.
So here we have 2 sig figs. We have 2 sig figs added to 2 sig figs. So my final answer should be,
Hey, and that's supposed to be a
99.
you said 99.
Yeah,
Yeah.
because it's above
That's
5.
Because this is greater than 5, we're gonna round it
You gotta change it to Fahrenheit. You put a C.
up. Oh, sorry. Thank you.
Ooh, that'd be really burning up if it was that in Celsius.
Thank you for the correction. Okay, questions?
No.
The final is at the end of the class.
Hmm?
Somebody asked, when is the final?
No.
In November.
What was that?
It's today.
Gonna stress people out. That's funny.
Okay. You guys ready?
Yeah.
Report? Okay, so when we talk about absolute zero or the absolute zero scale, that's the Kelvin scale, okay? And what happens at absolute zero again?
Freezing zero. Isn't the freezing point?
Of what?
Temperature.
Absolute zero, isn't that the lowest it can go to?
What can go to?
Temperature. I'm not sure.
So what happens? It's the freezing point of what?
Water?
No, 0 degrees Celsius is the freezing point of water.
Boiling water? Oh.
Again, 0 degrees Celsius is the freezing point of water.
Okay. So 30.
So anybody want to help her out? What happens at 0 degrees Kelvin? At absolute zero.
Ice
The
age.
apocalypse.
So yes, you're right. The apocalypse would happen. Why?
Why? Because the directors want money. You know, all the apocalypse movies. I'm tired.
Okay,
I thought you
So-
said hot pockets for a second.
Hot pockets.
That's what it sounded like.
But it's like, remember 2012, the movie?
oh yes, 2012 is a good example. So what happens at absolute zero?
A blizzard?
Everything would freeze.
Everything would freeze. That's true. And that also means that what happens to those molecules?
They shrink,
Solids?
they condense.
No, it's not that they shrink or condense. Somebody said something else.
Solids? They all become solids. I don't know.
Well, yeah, everything is going to become solid, but even solids move, right? So at absolute zero, everything stops moving. Right? You get no movement at absolute zero.
Even molecules?
Yes, even molecules.
Dang. All right.
Absolute zero is when everything stops moving. Okay, so the Kelvin scale basically is that point where we get absolute zero, where we don't have movement of molecules. And that happens at negative 273.15 degrees Celsius. Right? So what I'd like you guys to do is, can you calculate that into Fahrenheit? Negative 273.15 degrees Celsius. Can you change that to Fahrenheit? Using the equation on the last page. Oops, not that. Yes, no, maybe? How's it going?
I mean, it's just two people.
What was that?
Don't worry about it. Don't worry about it. Well, actually, maybe you should.
Okay, that's all right. We're gonna do a quiz here in a minute, so we'll see how many people are still on.
Dang.
Amazing.
Okay, do we got an answer?
If I did the right thing, then yes, I have 1.
Okay, so we said
I
it's
don't-
negative 273.15 degrees Kelvin, I mean Celsius. So we're gonna go ahead and plug that in here. So we have negative 273.15. We're gonna multiply that by 1.8. And we're gonna add 32. What did you guys get?
Negative 49135.
4,
So it's still super duper cold.
said super duper cold.
Mhm. Well, it's still negative.
That's right.
Can never wear shorts again.
So negative 459.67
Yeah.
degrees Fahrenheit.
Yeah. Wait.
Yeah.
Sure. Mhm.
Okay. So if we did sig figs,
5?
2.
okay, it would be 2 again.
Oh.
This is gonna give us 2.
Question, you're getting the 2 from the 1.8?
Yeah.
And 32 also.
And the 32 also, because we hit 1.8 times times the negative 2. So then that's gonna be what, 491 something.
Okay.
And so then we would use 2 sig figs with that. Yes. 8 times,
I might just call it for tomorrow.
sorry, 67. Okay, so 491.67. So this guy would be 2 sig figs. So we'd end up with 490.
Where did the 90 come from?
Negative 490, sorry. Negative 490. Right, because 1.8 times negative 273.15 is going to be negative 491.67. Now we would take the number of sig figs from here. That'll be 2 sig figs, so that'll be negative 490. Then you add that to 32.
Are you Xing?
What was that?
Are you Xing or
Yeah, I'm asking. So then if I add that to 32, right,
negative 458?
so that'll be negative 458, right? So then we know that here, that would be our point. So then 400 and, sorry. 50 degrees. So if we have negative 458 degrees Fahrenheit, so here we're adding these two together, so that one spot is going to be questionable. So we take this guy and we either round up or leave it alone. So we're going to round it up or leave it alone.
You round up.
So then that would be 460 degrees.
Yeah.
Okay, so not too bad from our answer at the very front, at the top.
Would it still be negative?
It would still be negative. I forgot. Thank you. Let me move it out of the lines way so you can actually see it.
This was checking. I couldn't tell if it was the equal sign or not.
Can you repeat how you got negative 491?
How did I get 491.67?
Yeah.
I multiplied 2, negative 273.15 times 1.8.
Oh, okay.
So that'll give me that. And then I added my 32. Right? So, but then I knew I needed to
Okay.
right? So I knew I needed to round this number, right? Because I had two significant figures here. So I had to have two significant figures down here.
Okay.
Okay.
Yeah, thank you.
Okay. How's everyone doing?
I don't know if I can, last the whole class.
That's right. We're going to take a 5-minute PP break.
Well, no, I mean, like, I don't,
But that's right. We're still going to take a 5-minute PP break. So I'll see you guys back here in 5 minutes. And then what we'll do is we will go over a couple more things, and then we're going to do a quiz.
Dang, we should just
Okay, so let's
chat the rest
stop
of the
shop
time.
here. Yeah, it's a little
What'd you
Why
say?
not do
modified.
this? I'm not really feeling well.
You have to take the quiz, Gabriel. Suck it up for 20 minutes.
I mean, I'll try it. Is
All right, you
this
can do it.
count?
Let's go.
Is this counted towards our grade?
Fake it till
Of
you make
course,
it.
it counts
Positivity.
towards your grade.
It is.
Yes.
Can I
Okay,
use the
so-
DSPS? Like,
Yes. Yes.
all right, I'll at least try it here.
When we
Yeah,
talk
write all the
about,
questions down.
okay, when we talk about the Kelvin scale, right? To change
Yes.
Celsius to Kelvin, all you need to do is add 273.15 to it. Right, so this should be 0.15. So if we have 37 degrees Celsius, so then it's going to be TK, that means temperature in Kelvin, is going to equal 37 plus 273.15. So that's going to equal
It's not 300. It's not. I wish.
310.
Yeah.
Have you guys seen that meme? Like 77 plus 33. It's not 100.
Yeah.
Yeah.
So 310, right?
I'm
So then
tempted.
again, the one spot. So then here we take a look at the 10th spot and decide whether we're going to round it up or leave it alone. So we're going to have 3 sig figs. So it'll be 1, 310, and we'll put that decimal there. Let us know that it's 3 sig figs. Okay, questions?
I thought we were supposed to have 2 sig figs.
No, this one here, so if you look at it, it's addition, right? So we did 37. And then we have 273.15. So if we're drawing those lines, okay, we have lines that are going there, and then we're going to have our other line going after the 5, right? So then we're going to take the one that's furthest to the left. So that's going to be our pink line.
Ah, I see it now.
See it now?
Yeah, the lines help.
So then that's what, 310, 15. So then we use that 1 to decide.
Mhm.
Okay. Questions, concerns?
Yes,
Yes.
quick question. 37, where did we get that?
Just
I
around.
said that was the temperature that I was giving you guys. I said if we had 37 degrees Celsius,
Just the
Oh.
example.
it was an example, yes.
Okay.
How many questions are in the quiz and how are we doing it?
The quiz only has 2 questions.
Okay, okay.
Sweet. Awesome.
Yes, but we got to get to the point, last point, so that way you can take the quiz, right?
Yes.
I'll try.
You can handle it. You can handle it. We're almost there.
You got this, Gabe.
Oh,
Woohoo.
there's still like an hour to go. Or more.
Technically, there's an hour to go. Yes.
Technically.
I don't
Technically.
know if I can. I don't want to stress myself.
Wait, hold on. Just wait. Let's get through this part first. Let's get through these last couple of slides. We have only a few more slides left. Okay.
All right.
For this chapter. Okay.
288K. That's Fahrenheit.
So at 288K, I want to convert it to the Kelvin scale. So we want to change it to Kelvin. So here, since we know that, I'm sorry, 288 Kelvin, want to convert it to the Fahrenheit scale. Sorry. So here, I'm starting out with Kelvin, right? And I need to go from Kelvin to Celsius, and then Celsius to Fahrenheit. So what am I going to do?
Subtract.
Kelvin to Celsius.
Right, I'm going to subtract. What am I going to subtract?
273.15.
270, that's right. I'm going to subtract. So I'm going to go 288
88.
Kelvin minus 273.15.
See, I was thinking that, but I thought I would be wrong as usual.
14.85.
Nice.
And that's degree C. So again, if we do additions, it's to the 1 spot, right? Where we're going to have it. So both of these are going to go up to the 1. So we'll take a look at this guy. We're going to decide whether we're going to round or leave alone, or we're going to round or leave alone.
Round.
Round
Round
up.
15.
Okay, so it's going to be 15 degrees Celsius. Okay, so now we can plug that Celsius into our equation. So we know that if we go 15 degrees Celsius, we multiply that times, what do we multiply that times?
1.8.
1.8, that's right. And then we do what?
At 32.
Add 32. That is correct. Fuego, you guys are getting this. So that's going to give me my TF.
Oh.
So what do you guys end up with?
59. Degrees Celsius or Fahrenheit?
Fahrenheit, right? Because we're converting from Kelvin to Celsius, then to Fahrenheit.
That is correct.
Wait, I have a question. So for Kelvin, anytime you want to get Fahrenheit, you always have to convert Kelvin to Celsius and then Fahrenheit?
That is correct. Or what you
Okay.
can do, you can modify the equation so it can go directly from Kelvin to Fahrenheit. So, but that's just going to take a little more math.
I've got
That's cool.
I've got 2 questions.
Yes.
So where did you get 1.8 and where did you get 32 plus 32?
Because on the slides, 2 slides before this,
Yes.
we have this equation here. We have TC equals TF minus 32 divided by 1.8. So if we modify this is the way of converting from Fahrenheit to Celsius. But here we want to go from Celsius to Fahrenheit. So we want to change this equation around. So if we change this equation around, we get TC times 1.8, because we're going to multiply both sides by 1.8. So that's going to cancel this guy out. We're going to multiply this side by 1.8. And then we're going to add $32 to both sides. Okay, so then that's going to get rid of the 32 here. Then we're going to add 32 over here. Okay. So then we're going to get 1.8 plus 32. And that's going to equal our TF.
Okay. I might still be confused, but I'll probably just go over that with Angelia during tutoring so I can practice more equations like this.
I'm screenshotting that because I'm not gonna remember.
What was that?
I saved it. I screenshotted it because I won't remember that.
Yes, you can
Yeah.
it as well. So you can actually hit save and your annotate if you have access to annotate, or you can
Yeah, I did that.
or you can do a normal screenshot.
It's in my folder.
Okay.
Oh yeah, I forgot screenshot.
Okay, let's move forward.
Okay.
Good Lord.
Damn.
Okay, so here we have this table. You guys have Celsius. I'd like you guys to do the work to fill in the Fahrenheit and the Kelvin. Here you have Fahrenheit. I want you to do the work to fill in the Celsius and the Kelvin. Here you have Fahrenheit. I mean, you have Kelvin. You have to go back to Celsius and to Fahrenheit. Okay,
Yeah.
everybody take a screenshot, and I'm going to put you guys in groups.
Groups.
Yep.
Hold
First
on, hold
one,
on.
I'll give you guys, we'll say 10 minutes.
Screenshot of the blank one?
Yep, take a screenshot of the blank one. And don't cheat.
Sure. Gee.
I would never.
Oh no.
Okay.
So now I'm gonna put you guys in groups and so you guys can discuss how to do it.
Okay.
Awesome. Thank you for the practice.
Let's see how to do this. Everybody got a screenshot?
Sure.
Yes.
Rooms. So we're gonna produce 4 breakout rooms. We have 5 in each one.
Wonder who's gonna be in my group.
So I'll
Brooke.
give you guys 15 minutes.
Oh, I never get picked first for dodgeball. This is great.
Bro, I want to pick Brooke, Gabriel, Euphoro, and Sarah, just because you guys are like the first ones on my.
And
on my list.
Adalia.
And I
Adelaide.
did.
Okay, so what are you guys doing first, Fahrenheit or Celsius?
We should do like, we're supposed to do Celsius first and Fahrenheit, right? And then we have to backtrace our steps for the other two. I assume.
I understand it, I just needed to see my notes.
To Celsius, and then to Kelvin, and then 364 to from was it Kelvin to Celsius and Fahrenheit. Professor?
Yep.
There?
I'm here.
Are you able to listen in on everybody's
No,
group or no?
I'm just moving to everybody's group, that's all.
Oh, I see.
Yeah.
You,
So,
we're kind of-
Can I give you guys a suggestion? Okay, so can I give you guys a suggestion? Okay, can you share your screen and can you share the image that you just took, the screenshot?
I can't find my screenshot folder. No.
So if you do a search and just type in screenshot.
Oh man, this is what you need.
Okay, how about I come in and
Photos.
Yes. Yes.
Very
Although you
sad.
cut me
Yes.
off.
You're off, I'm
All
sorry.
right, last row. What was it again?
Why can't I only?
You want the full equation,
I mean,
Gabriel?
I messed up somewhere. So it's 91. It's still 91.1.8 plus 32, right?
Yeah,
All right, then it should be fine.
you'll get 196.
All right, thank you.
Mm-hmm.
I want to know who had whose group.
I don't even remember their names, but
That's all right.
it's Sarah. Never mind. So it's never mind.
Had Janet, Pretty Ricky, Adelaide.
Oh yeah, I had Jack
Cool.
as well. People who aren't here, you know.
There.
They're here in spirit.
Indeed. He's down
Yeah.
under.
I gotta say, this doesn't really take 15 minutes to do.
It doesn't take 15 minutes to do.
It takes 2 to 3
No.
minutes. I'm not
The
gonna
lo-
lie. I
The
was
longest part was finding the screenshots.
See, but I want you guys to learn how to use those screenshots. It was a learning experience.
I should have
Yeah.
saved
And then
it.
I had to pull out my notepad.
Okay, so you guys are able to convert temperature, right? No problem?
Stuff, dude.
yes.
Yeah.
Okay, good.
Hopefully.
No.
Couple of comments.
I will positively say that. Oh, I got it. Well, I was never mind.
That's good. You're not dumb. You guys should feel smart. That's a good thing. Okay, so the last thing or one of the last things I want to talk about is density, right? And proportionality. So proportionality is looking, that's the best way to say it. It is, write something down. E is proportional to N.
C squared.
We're going to use velocity squared. Okay, so E is proportional to M squared, right? And so to make this true, meaning the energy, in this case is the kinetic energy, is going to be equal to the mass times the volume squared, we have to have it a constant. So it's E equals 1/2 mv squared. Okay. So as the energy goes up, we would expect either the mass or the volume to go up. Okay, or maybe both. Okay, so as the energy increases, the mass is also going to have to increase. Okay, as energy decreases, the mass is going to have to decrease, or the velocity has to decrease. So if we're going to keep it at the same speed, v equals velocity here. Are you guys yawning? I know you're not yawning.
No, clearly.
Exactly. You would never yawn when I'm giving a lecture, right?
Of course. Definitely not.
Okay.
Never.
Good, good.
We would die though.
Okay, so that's good. So you guys are lucky you're not in class right now. Because, you know, I do have this coffee mug, and I've been known to throw a coffee mug every once in a while.
Oh dear.
I'm joking.
Well, I'm not allowed to drink in class.
Is
so-
it, is it hot coffee or do you like iced coffee?
I like them both actually. But since we're like on lecture, we can talk about me throwing a coffee mug, right? So let's say I did get upset about you guys yawning in my class. I decided to throw a ping pong ball at you, right? You guys know approximately how much a ping pong ball weighs, right?
No.
No?
Maybe 1 gram.
It's like very light. It's like
Yeah.
not even solid.
It's about 2 grams roughly.
Oh, I was off by 1.
It's approximately 2 grams. It's like
That's a
2.45.
guess.
Okay.
Thank you.
So a ping pong ball is pretty light. It's not too much, right? But my coffee mug, so that one is about 800 grams. Okay. Now I want you to think about it in terms of the energy. So if I'm throwing them both at the same speed at you, right? We'll say it's going to be 4 meters per hour. Okay, 4 meters per hour. Okay. So I'm throwing them both at the same speed at you. which one is gonna have more energy behind it? The coffee
Mug.
or the ping pong ball?
What are you asking for? Energy?
Energy,
I would say
I
the
think
mug.
it would be the mug.
okay? So it would be the mug, right? Because the mug weighs more. So now the thing is that if we look at it, the ping pong ball, it weighed 2 grams. The mug weighed 800 grams. So we're increasing our mass. So as mass went up, our energy, so that would be directly proportional. Okay, so as mass went up, energy went up. So that would be a sign of being directly proportional. You guys understand that?
You said directly proportionate?
Directly, direct.
No.
They put ly at the end, directly proportional. Okay,
Mhm.
okay. Now, if we look at our mass and our velocity, okay. Now here's our energy. So if we're keeping our energy constant, let's say I wanted to hit you with the same amount of energy, the ping pong ball and the coffee mug. Okay. Now which one is going to have a faster velocity that I have to impose? The ping pong ball or the coffee mug?
You're throwing them both at the same speed, though.
You'd have to
I'm no
throw,
longer throwing them at the same speed. I can throw them at different speeds now. But
Oh,
we want
okay.
the same amount of energy.
What?
I want the same amount of energy, but I can throw them at at different speeds.
Energy. Different speed.
So we have different speeds for them, right? So we're gonna have different velocities.
With stopping power of air, like wouldn't it slow the ping pong ball down significantly?
Okay? We're not taking into consideration that there's gonna be any wind or anything like that. We're in a vacuum. I'm throwing it, and I'm throwing it really, really hard, right? So we're not gonna worry about that part. So if I want to hit you with the same amount of energy, the ping pong ball and the coffee mug, which one is going to be going faster? If I'm hitting you with the same amount of energy. Let's see, Javier says the ping pong ball because it's lighter. So because it's lighter, I'm going to have to use more velocity, more speed to make up for that energy, right? Than the coffee mug. So the ping pong ball is going to be moving faster to make up for it. Are you guys with me, right?
Sure.
Sort of.
Sure. Okay, so if we think about that, right? So if we had constant energy, if energy is being kept constant, both of those are the same. As the mass decreases, the velocity did what?
As mass decreased?
As mass decreases, then the velocity is going to do what?
Greater?
Velocity is going to increase. So in this case, mass and velocity are going to be indirectly proportional. As mass increases, velocity is going to decrease. Okay? As velocity increases, mass is going to decrease. Does that make sense? So they're going in opposite directions of each other.
What?
Okay, again. As velocity increases, the mass decreases.
Ah,
So would that kind of be like if you dropped a weight in a pool, it sinks immediately, but if you dropped a ping pong, it would stay on the top of the water?
Yes. So because they're indirectly proportional to each other, we're gonna have to put a lot more. So in other words, if you're talking about that weight in the pool and because the force of gravity on both of those, right? Force of gravity is gonna be more on that weight because it's heavier, right?
Yeah.
Push it down more than that ping pong ball. So we'd have to put some force to make up for it. You know, we have to throw it really hard to sit there and make up for it to go to the bottom.
They would still float back up.
Yeah, and then it would still float back up. You're right. But in that context, for them to have the same amount of energy, we'd have to compensate, right? And so these guys, since they're on the both on the same side of the equations, and they're being multiplied by each other, they're going to be indirectly proportional. Okay, where energy is directly proportional with both mass, and it's also directly proportional with velocity. So as one goes up, as energy goes up, if I keep my masses exactly the same, then that means velocity would have to go up. If I kept my velocity the same, that means mass would have to go to compensate. So that would be directly proportional. Okay, so let me give you another example. So if we're talking about density. So
Did we
first,
already do the quiz?
you have not done the quiz yet.
We're
almost there. Come on now.
Well, you know, it's like
I just need to finish these last slides and then I'll give you the quiz.
that's an hour though.
Just chill. Relax. Okay, relax. You're almost there. It won't take you an hour to finish the quiz.
I mean, I'm relaxed, but like I'm still sick.
I know, but then you'll be sick at home and then you'll go to bed and get some soup and you'll be fine. Okay, so if we talk about mass and volume, well, mass and volume are proportional to each other. They're directly proportional to each other. Okay, so as mass goes up, volume goes up. And so to make this happen, we need a constant. And that constant, in this case, is density, D. Okay, so D stands for density. So then you can say density is going to be equal to mass over volume. Okay, so density is equal to mass over volume. So as mass goes up, the volume goes up. Okay, so let me give you an example. So the density of water is 1 gram per milliliter. Okay? So if the density of water is 1 gram per milliliter, if I have 50 grams, what has to be the volume if density is constant?
$50 grams.
That's right. So if we have 50 milliliters of water, then it's going to weigh 50 grams. Okay. If I have 100 milliliters of water, how much is that going to weigh?
100 milliliters.
If I have 100 milliliters, it's going to weigh how much?
100 grams.
100 milliliters.
It's going to weigh 100 grams. Remember, weight is going to be grams. Milliliters is volume. Okay. So if I have 1,000 milliliters, then how much is that going to weigh?
1,000 grams.
1,000 grams. Okay. So in other words, as the mass went up, the volume had to go up to compensate for it. Keep that constant. Okay. So mass and volume here are going to be directly proportional to each other. Okay. So let's talk a little bit more about density. So density is going to be mass over volume. The units that we normally express it in is grams per milliliter or grams per cubic centimeters. Now density is dependent on temperature. So if I change my water to steam, my density is going to be different. Or if I change my water to ice, my density is going to be different. Okay. So here is an example. So we have ice, right? And so those molecules are going to be organized. They're going to closely compact. The density of ice is going to be different than of water. So here, this is water. So those molecules are going to be really close together, right? They're not going to be as compact as, well, they're going to be not as compact, or they're going to be more compact than the ice, because the ice has that nice organized structure. So as a direct result of that, ice floats on water, okay? So that means ice is always at the top of our water, where if we had a solid cube of ethanol, it would actually sink to the bottom. And here's just basically showing that. So if we froze ethanol, ethanol is alcohol, drinking alcohol. So a 100% ethanol, it's actually going to sink to the very bottom, where ice is going to float, because ice is less dense than water. Okay, so if you take a look, this is one of those tables of density. So helium is less dense than air, which is less dense than wood, which is less dense than water. Okay, so a boat or a piece of wood that's floating in the water. So why does that wood float? Why does that piece of wood float?
Because
It's a
it's
higher
less
density.
dense than water.
Because it's less dense than water. Okay. So if I throw a piece of glass or a bottle of glass into water, what happens to it?
It would sink
It sinks.
Eventually it sinks, right? Why does it sink?
because its density is greater than 1.
Okay.
Well said.
So the mass of 50 mils, 50.00 mil sample of ethanol is 39.59 grams. Determine the density of methanol. So how would I determine the density?
Mass divided by volume.
Mass divided by volume. Okay, so then 39.5 grams
Divided by 50.
divided by 50.
Milliliter.
Okay.
I do not have that answer. Let me try.
0.7918.
You're quick.
It's grams per milliliter. And we should have 4 sig figs. So it works out.
4 sig figs. Okay.
Okay. Next question. So the density of a certain machine oil is 0.90 grams per milliliter. Find the volume occupied by 196 grams of that oil. So how would I set up this problem?
Oh. Would you?
So 9.10 grams is equivalent to a milliliter? Is that what it's saying?
Grams per milliliter.
0.910 grams per milliliter
I want to see.
is equivalent to what? Is equal to
1?
1 gram.
196 grams.
It's 196 grams. So then what would be the volume at the bottom? So we're solving for volume since we have the grams on top. So that would be, sorry, that should be 1 milliliter. So how would I solve for volume?
196 grams.
Would you multiply across?
Then multiply across, yeah.
Okay, so I'm going to multiply across, so I multiply volume to get volume by itself. Okay, so volume comes over here, and then I get
178.36. Last time I multiplied it wrong. Hold on, let me write it again.
divided by 0.910. 0.910 grams times 1 milliliter. So then grams are going to cancel out. Then I'll be left with just milliliters. So you had one, what did you get?
Wait, are you multiplying across or dividing?
You're going to have to do both, right? So we're going to multiply both sides by an ml, right?
Okay.
Instead of an ml. So 1 ml by both sides. 1 ml.
Oh, I did the 910 times 196.
Okay. Then we're going to have to divide by 9.910. So we're going to divide both sides by 0.910. 0.910 grams. Okay, so then this cancels this out, this cancels this out, and so then we multiply both sides by volume. So we multiply this side by volume, and we multiply this side by volume to get volume all by itself, right? So then on this side we just have volume, and then you have 196 divided by 0.910 times 1 liter. So then
215 milliliters.
215 milliliters. That is correct.
Do we round?
Okay, how many sig figs should we have?
4?
3.
3. And how many do we have?
3.
3.
Oh dear.
Okay,
Yeah, that works.
that works.
Yeah. Let me screenshot that.
So, you guys ready for your quiz?
Just
Yes.
do it already. Come on.
Oh,
So excited, right, Jack?
Take it easy.
I'm not
man.
excited.
Take it
I just want to get the
easy.
fuck out of here.
Patience.
Hey,
Patience.
Gabriel,
Apologies.
you got this. dude.
Gabriel, you don't have to
Some
stay. You
patience.
can leave. It's okay.
No, because then it's like grading and stuff.
Okay, then you shouldn't be cursing in class.
your first question.
It's like I want to get knocked out, you know?
Can we write this on the packet or?
This is the quiz on like a separate sheet of paper, right?
Yes, quiz on a separate sheet of paper and you just upload it. Or you could take a screenshot.
Okay.
and upload it.
So we just write the answer, correct?
Hey, okay, you got my keys? Yes, just write the answer. What was that? Would like to get this? Give me the good news. That's good. What's the bad news?
It asked to mention $75 and an hour of my time.
Why did you question? Okay, we'll talk about that.
Is that Mauricio? Yo, Mauricio, what's up, dude?
Talking to that.
Mauricio, we never finished that presentation, man.
Oh, Gabriel. Hey, Gabriel, how are you?
Okay, so these are your two questions.
Hey, man, I'm sick. I'm tired. You know?
Okay, so let me put up the upload. So it should take you about a whole whopping 2 minutes, right?
Where do we submit it?
Oh, dude, I had density is defined.
Hello?
Hello, give me 1 second. I'm trying to get.
All right.
Oops. So did everybody get the question right? I need to make this fun. Stop sharing. Okay, remember, they hear everything you're saying.
What's I say?
I know.
Oh, so basically there are like 3 answers for number 2.
That there are 3 answers for number 2?
Yes.
What do you mean by that?
Well, we have Kelvin, we have Celsius, and we have Fahrenheit. And the meaning of oh no, not number 2, my fault. I'm talking about absolute zero.
So not you shouldn't have 3 answers. You should be able to find what absolute zero is.
Oh, serious?
Yes.
Oh boy.
What was
What's
this?
it on Canvas?
What's that? This is quiz number 4.
Where's number 4? Oh dear.
Wait, what? Wait. This okay? So this is on Canvas.
Yes.
All right, and it's just the 2 questions.
It's just 2 questions.
All right. Is it like 90 sentences that we gotta like, fill her out,
Say 90 sentences.
or is it just 2 sentences and it's fine, right?
I don't want anything that's 90 sentences. If it takes you 90 seconds to answer these 2 questions, then you may want
I'm joking, of course, but there's always, it's like not being enough. Also, I have a roommate. He's very loud. Talks too much.
What was the second question?
Density is defined as what?
Okay.
Oh.
So for the first one, there's 3 answers, right?
No.
My fault.
No.
I just confused literally the whole class.
There's only
My fault.
1.
There's
Wait,
only
Dr.
1.
Henry, I have a question.
Yep.
So for the homework number 4, atomic theory, do we just read the book?
For homework number 4, it's
Yes.
gonna be, you can read the book, but we're gonna go over it on Thursday. So your homework is gonna be shifted. So since we just finished chapter 3, I'm gonna give you guys a couple more days to get chapter 3 done. And then I'm also gonna extend your chapter 4 homework.
Okay, thank you.